All right, welcome back, everybody. Today is October 10th, and we really briefly started the other day aquatic ecosystems. Remember, 71% of the water on our planet is, 71% of the surface of our planet is water, and of that, only 2.5% of it is fresh. And even more than that, 0.3% is surface water, which is like tiny. So, like, notice how small of an amount this is. This is 0.3% of 2.5% of all water. So that's like almost nothing. Okay, we started talking about streams and then we did the presentations. So if you double check in your notes, can you guys confirm the last thing you have is rivers and streams start at headwaters and end at the mouth? Okay, cool. Now, as we go through here, we're going to continue on right there. Philam fun fact today. I didn't know this. If I were to go to Manila right now, what would I see downtown people already starting to celebrate? Christmas is already being celebrated in the Philippines. Like September, it starts.
They call it the Burr month.
Yeah, that is crazy to me.
My dad's celebrating Christmas right now.
That is bonkers. Like it's not really bonkers, right? It's just different than my culture, so it's not. It seems strange to me, but there's nothing intrinsically strange about it.
I woke up with Christmas songs.
I have been whistling Christmas songs lately, so maybe it isn't that strange. Quick random things, because I've never been to the Philippines. I've never been to the Philippines at Christmas. Santa. You guys grow up with Santa?
Yeah.
Okay. Does Santa still wear a big, heavy coat?
Yes.
He still does, even though it's super hot?
Yeah.
Weird, okay?
My dad dressed up as Santa when in our village one time and gave out candies to the
Cool.
kids.
Nice.
Even though it's so hot.
Yeah. I'll tell you, I went to Brazil for Christmas last year, and it was really weird for me. Everywhere I've lived has always been cold and at least the possibility of snow. But it seemed really weird to get up and then go to the beach on Christmas. It was a weird idea. Just so much different. I need to work on not weird, different. All right. So we were talking about rivers and streams. Now we are going to look at these a little bit closer. They begin at the headwaters, which can result from a few different ways. Headwaters, here especially in Unalaska, this river is fed by what? Snow and snowmelt specifically. Okay, is every river on the planet fed by snowmelt? I'll tell you, where I'm from is called Hot Springs, South Dakota, and the rivers are not fed by snowmelt. We do have mountains, so there's some, but there's a river that runs through my hometown that's really crazy. It's not really hot. It's 86 degrees, which is, we're 98.6 is our body temperature, but the river in my hometown is always 86 degrees. Middle of summer, 86. Middle of winter, 86. Which means in my hometown, during the dead of winter when it's really cold, the river steams all the time, and the trees along the river, then that steam condenses on them and they freeze, and it's awesome. It's super cool looking. Why is the water always 86 where I'm from, do you think?
Wait, are you south?
It's northern U.S. It's South Dakota. What do you think?
Does it rain often though?
So not really.
Temperate.
What do you think feeds the river?
Underground water.
Oh, what do you call that source of underground water where water literally bubbles out of the ground?
Spring.
A spring, and my town is Hot Spring. So you could have headwaters that are springs as well. That's the headwaters of my hometown. That's what they do. It's pretty cool. Now, beyond that, as we start going through this, we're going to make a couple different statements. I want us to think about headwaters of a river. Specifically, I want us to think about that snowmelt headwaters. Springs do exist, but we'll make this comment. Start at headwaters. These could be springs or snowmelt. Those are what the headwaters can be. Now, depending where in the world you are, the mouth of Iluluk right here is literally the ocean. Most rivers lead to the ocean. At some point, they'll get there. What winds up happening is if you have a small river or stream, its mouth might just be a larger river or stream, whose mouth could also be a larger river and stream until everything gets to the ocean. So, we're going to think about rivers specifically with the snowmelt idea in mind. And I'll go back to blue so it's consistent.
One of those videos where people create a wave by
destroying the beach?
Yeah.
Hate it. Hate it. Super cool, but they're destroying the beach. Like,
They like dig out to a stream of water.
yep.
and-
It's a cool idea until you think about how much destruction they've caused in the process of their stupid YouTube video. All right. Sorry, that's yes, I have seen those. Now, let's imagine we're on a snowmelt stream or river. Okay. If you're gonna have melting snow feeding a river, it's probably gonna be where? Is it gonna be down low or is it gonna be up in the mountains?
Up and down.
They're gonna be up in the mountains. So it means as that water starts to flow down, it probably has a steep incline, right? Okay. Snowmelt specifically feeds a stream or a river. I'm gonna say feeds a river with water that runs downhill. And I'll just say running because I think that's shorter overall, but I could be wrong. Do you guys agree with that statement? I don't know if anybody in here has ever been on a hill. Obviously you have, right? If you're have a marble and you put it on a hill, and we'll just say it's a nice smooth hill for this idea, what happens with the speed of the marble? It goes faster and faster and faster. What do you think happens with this water? It goes faster and faster and faster. So as this water moves downhill, it picks up speed. Downhill, picking up speed. Now, there's more that we could say about it. I don't want to write more, but if we're in a snowmelt river, like at the very beginning, you might have a really, really little tiny amount of water, right? It could be literally this wide and just a small little drop. But the more you go, more water starts to pool in, it gets bigger and bigger. So all of a sudden you could have like really fast, really big river going down the hill. Okay, when you look at that, is there stuff that the water must run over? Like are there rocks and dirt and stuff? What does water do to that as it runs over it? Starts picking it up and it erodes. Now, that happens and it happens and it happens. As this goes downhill, debris, so we're going to say rocks and dirt. I'm going to say rocks with the understanding that it's really all earth. Rocks are picked up or pushed downriver. Okay, we all agree with that statement. Now you might have a big rock that isn't straight up like moved because it's a gigantic boulder, but we don't get to see this normally in realistic time. But imagine you have a big rock in a river and really fast water rolls over it for 10, 20, 30 years. What happens to the rock? It starts to get smooth and smaller, right? Now, what happened to all the other rock that was there before it was smooth?
It combines.
What do you mean combines? Maybe.
That's the
Somebody said the word that starts with E a second ago. It erodes away. Like all the river or all the stones on the beach down here, they're super smooth. There's a reason for that. It's because the waves crash on them and crash on them. Okay, they're pushed or eroded downriver. Over time, erosion makes smaller and smaller pieces. I'm going to say smaller and smaller rocks. And this has a specific name. Eventually, it gets so fine and so small that it's like really fine dirt or sand, right? What do we call that? Starts with an S. You- Sediment. It is sediment. And I'm just going to sink that in. Sediment. Okay. Now, we have a really fast flowing river that's carrying all of this sediment down. It means that most of the sediment is not going to settle up there where it's going fast, right? Eventually, though, this river, downhill, 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 it has to slow down at some point because it's going to reach flat ground for a minute. When it slows down, what do you think happens to all the sediment that's been carried by the river? It'll start falling, like precipitating and falling out of the water, right? Now, specifically, it just falls down to the bottom. But this is why when you're looking at rivers, there's some places where you get a lot of rocks. But if you go down to the very base of it, oftentimes it's like feet of mud that people get stuck in. Like where I'm from, it happens all the time. Now, as it slows down, sediments deposit as the river slows. Sediments get deposited or just deposit as flow slows. All right. Now, there's all sorts of crazy things about this that are beyond just this idea. So we know that it means you're going to get really muddy sorts of situations when the river runs slow, and you'll probably get rockier, less dirt sort of situations if the river runs fast. Okay, beyond that, there's a lot of other stuff that we have to worry about. So I'm going to make sure I stay consistent. I'm just going to say characteristics of rivers vary wildly. Now, wildly. When, I'm going to let you guys catch up because I have a bad habit of doing that. If you want life on this planet, you need water, right? Like, cool, we got a lot of water in every river. Are there rivers that don't have much life? Like, if we are in a really fast flowing river, are you expecting to find a bunch of fish in there? Probably not. Why? Yeah, the current's going to carry them away, right? It's hard for them to live. Beyond that, are there places where maybe the river slows to almost a complete stop? And you could find life, right? But is it possible that you have a river that runs really slow and there's not much life in it? Why would there ever be a slow-moving river that doesn't have much life? Love it. Maybe the environment isn't well suited for life. I'm going to give you guys about 60 seconds. What sort of things in an aquatic river, so that was redundant, what sort of things in a river would make it so that life doesn't really succeed? You get a minute. Those abiotic and biotic factors, preferably abiotic. What about the river would make it so there's not much life? That's one of these little pieces. Characteristics can vary wildly. So we're just going to break this into a couple of smaller pieces. Fast rivers. No nutrients deposited. Why? Because of current. 100%. Okay. Now, if there's no nutrients, then there's not going to be anything growing, which means, again, that whole food chain just doesn't exist, right? Okay. Beyond that, though, this is an interesting one. There's no nutrients, which is kind of a bummer. Fish breathe. True or false? Fish do breathe. What do fish breathe? Water. Now, here's just an interesting idea, and we're not going to go super into the chemistry of it. Anybody have a fish tank at home? Okay. Did your fish die? My condolences. How fancy of a fish tank did you have? So you had a big fancy one. Okay. Was there light in it?
Yes.
Okay. Was there a little tube that would bubble?
Yes.
Why?
Filter.
It's not. It could be a filter.
There's supposed to be a certain amount of air at the top, and then the rest is like water.
So let me. You're right. I mean that definitely happens. Is there air in water?
Yes.
Yes. Now, water's made of H2O, right? Now the oxygen that fish breathe, because they do breathe oxygen, but it doesn't like literally separate from the water. If it did, that'd be terrifying, because if you took all the oxygen out of H2O, you'd be left with just hydrogen, and that is super explosive and a gas. There would be no liquid if something lived. So what winds up happening is when you have that little bubble thing, it could be a filter, but more often than not, it's there to just pump air down and it bubbles up because oxygen and other gases dissolve into the water. Like, water holds oxygen other than just H2O. So, in a really fast river, what color, and this is, or, I don't know, I like that language. When you think of a fast river, what might people do on it? For recreation, for fun. What do people do on a really fast river? Might put your hand in it. There's probably more fun stuff you can do. If you could surf depending, maybe throwing rocks is a little bit more fun. You could build a dam. I don't know that that's really fun. That's super useful. Kayak. Like people kayak and canoe down rivers, right? Or tube or whatever it is. When you think about a river that somebody might kayak down, what's it look like?
It's like dangerous and
What color is it?
yeah, brown.
White.
I like that answer. It could be brown because of all the mud. Why white?
Because
Holy bubbles. You get a lot of overturn, right? Which means there's a lot of air being pushed down into the water. So what's weird about this is even though there's no nutrients, there is a lot rather, of oxygen dissolved. I'm going to say dissolved oxygen. Now, this is an important idea. Dissolved oxygen is necessary because this is what fish breathe. Okay, aquatic animals, not plants, need this dissolved oxygen. Plants need dissolved CO2. All right, now if we move to a different river, or the same river, just later downstream, and now it's slow.
Mr. Holwood,
Yo,
I have a question. Since you said yesterday sunlight sometimes, or not sometimes, but sunlight can't penetrate, the ocean water, like the sunlight.
so it can penetrate some.
Yeah, some. But how do seaweeds live without sunlight?
They live at depths at which light penetrates. Like if you go down to the bottom of the ocean, like where the Titanic is, you won't find seaweed. Like you think you will, but you won't.
More like the low tide, like if you go to the
You have to be like essentially less than 200 meters.
Because there's like seaweeds that grows very, very big.
Yep. So, like you might get some populations of seaweeds and kelps, for example, that like that big bulb that you always find, it floats. So if it is there somewhere and its leaves like start pushing down, like it can grow down and their vascular system spreads the nutrients throughout them. So it's just like trees grow, but most of a tree is below ground, right? They're just the roots that the leaves collect it and then push everything to the roots. So yeah, great question though. Okay, as we're looking at this, so a slow river, there's lots of characteristics that can vary wildly. Is it possible there's a lot of dissolved gas in it already because it's come down from a big mountain? It could have oxygen, right? Now, there are situations though, in some circumstances, you might get that moldy looking river, which is just like a lot of algae, right? In some circumstances, algae might take most oxygen, might use oxygen.
or is it algae?
I'm sorry? It's both. It depends on where you're at. It's algae in the U.S., but algae makes more sense in my head when I read it. Okay. Now, it might be algae. It might be other types of, oh my gosh, detritivores and things like that. But you can have stuff that makes it like gross and look murky and ugly, right? Okay. If you have something that takes up all the oxygen within your river, is there going to be any oxygen left for everything else?
No.
So are you going to find a bunch of fish if this is the case? No, probably not. Now, this is not just always the case, right? Because we see rivers where there's fish all the time. Beyond that, other little pieces. It could be the water is too murky. So turbidity, if I say murky, do you guys know that word?
It's like kind of like a brownish, like it's the stuff that makes water.
Blurry.
Okay.
What I think of.
So turbid is a better word for it with specifically regarding water. But turbidity might influence the amount of what that gets in the water. So if you have really muddy water, what doesn't get deep into the water? Sunlight. Okay. Turbidity might influence the amount of sunlight that you get. So you could have a river that has a ton of oxygen in it, but it's so turbid that there's no plants. And because there's no plants, there's no like safe havens and the food chain just doesn't exist anymore. Okay. However, these are like the negative possibilities, yeah? There are certainly positive things. If the conditions are right, if good conditions, plants grow, which we're going to pause for just a second, and again, I'm going to talk way more than I write here. Let's say you're a baby fish, and you've just hatched, and you're in a river, like maybe you're a salmon over there. Are you safe?
No.
Who might eat you?
Other fish.
Other fish, possibly even other salmon that are swimming around, birds. Random things can happen to you, right? Where are you going to hide?
Murky water.
Maybe under a rock, maybe in murky water. If there were a bunch of plants around, would that be a good place to hide?
Yeah.
Oh my gosh, so plants offer a lot of that stuff. One, they produce oxygen into the water itself, so the oxygen's already getting better. Plants are growing, which means you might get insects in hiding places. Insects, they have a place to now hang out. Fish and other life thrive. Now, I don't want this to come off as it's one or the other. There are rivers that have like really, really successful ecosystems happening. There's rivers where the ecosystem just isn't great for life. Both exist, right? I focused on a couple of the ones that might make a negative impact, but they're not always negative. And it's not always negative all the time. It just depends on a whole lot of other factors working with it. Is that cool? That makes sense? Okay. All right. Now, beyond that, I think that's all I have to say about rivers right now. Who had rivers? I'm trying to remember. Anything that you'd like me to add? Does this seem all reasonable to the stuff that you talked about as well? Okay. Cool. All right. Moving on then. Rivers. They flow, they flow, they flow. Is it possible that they eventually reach a spot where it essentially just stops and then you just get a big collection of water?
Yes.
What is that called? Could be an ocean eventually, but before we get there,
Lake.
lake. So let's talk about some lakes and ponds. Lakes and ponds. Okay. RJ, what's a pond compared to a lake?
Pond is a smaller version of a lake.
Yeah, it's just a small lake.
Less eco, or how you go? Less organisms.
Yeah, I would agree. Smaller size means typically less organisms, lower biodiversity. When we look at this definition kind of bothers me, but we'll have to just accept it for now. When we think about lakes, are you thinking inland or like right on the ocean?
Inland.
Inland typically, right? So we're going to say that lakes are inland bodies of standing water. Okay, just so we're clear here. Lakes don't have legs. What do I mean standing?
It's just there.
Just there. Is it flowing? No, and this is a gripe that I have with it because lots of lakes do have little rivers that feed into them, and then you get this big lake and then a small river leaves it. We call them lakes. We can probably all agree that they are lakes. By definition, I would just say it's a really, really, really slow-moving, wide river. But it's a lake. Like, we can all pick it out. Okay, they are typically standing water, but they do not have to be. Now, is there a set size for these? What's the biggest lake you can think of? So I'm going to make a comment and say sizes vary wildly. And I think that's the second time I've used that today, so I need a new adjective. They can be really, really small. You could have a lake like 1 square meter, this big. You could call it a lake. It'd still be a lake. But you could have a lake that's much bigger. How big can a lake be? What's the largest lake you know of? And I know that like you guys were trying to think about it. Are there any lakes that you can stand at that you can't see the other side? What did you say? What did you say? I just didn't hear it.
Oh, like, yeah, you can't see some because of trees.
So because of trees? So check this out. 1 square meter is just this big. It's 3 feet by 3 feet. That's it. That's a square meter. It could be that small, but it could literally be tens of thousands or larger square meters. So check this out. We're just going to look at a quick picture. I'm going to make you guys close your eyes here in just a second. You don't have to, sure, you can close them now. Or just turn around and don't look at the board. Either one. Don't fall asleep. All right. I just don't want you to see what I'm Googling here. All right. Go ahead. What is this?
That's a lake.
Ocean.
That's an ocean, right?
That's a lake.
Oh,
This is a lake.
Actually, because I can see the other side.
So, yep, we can find others. So this is Lake Superior in the U.S. This is a lake.
I know.
Okay, when you look at them, they get huge. These are the Great Lakes. which are where?
What's that?
Who had lakes yesterday? What region of the country did you do?
I knew it.
You did the
I was
U.S.?
going to say not far. Like,
So, check it out. We're just going to go to maps because those are going to be easier. Oh, we should just go to Google Earth. Nope, I struggle with it. I struggle with it. Okay. Check it out. Cool. So we're just going to go through. Do you see any lakes from this far? Okay, the Great Salt Lake. It's a big one. Okay, super salty. This is left over because the ocean used to be here. Okay, just left a bunch of water, happened to be there. Okay, the Great Salt Lake, you could stand at the southwest or southeast side and look north, and you would see the sides of it, but I don't think you can see the other side of the lake. Like, it's that big. Now, check this out, though. Gigantic lake. Great Lakes. These are lakes, and they're awesome. They're huge. Ships have sank and never been found in the Great Lakes. Like, they're essentially as big as the ocean, but it's freshwater. Now, they're literally not as big as the ocean. Like, I can tell that they're not. But when you're on it, like, large body of water is a large body of water. Now, in these guys, some crazy things that happen. There's 5 of them. I don't remember all the names of them off the top of my head, but that's all right. They're so big that they get tides. Like, you have waves. People can surf in the Great Lakes. It's a lake that you surf in, not the ocean, a lake, because they have so much water that the moon and sun create tides in them. Beyond that, it also gets really cold up there. There are times when these big waves that just haven't crashed freeze. And you get freezing that, like, literally waves frozen. Yeah, it's super weird. I just got the shivers thinking about it because of how cool it is. Like, I'm not even kidding. Yeah. So check it out, Frozen Waves, Lake Superior. It's crazy. Like, no, only if it never melts. But like, these are, like, you can see this is frozen solid, but there's waves that you can still see. It's insane. Here's an example of it. Like, they just freeze in place, and there's some really cool stuff that happens because as you start getting it, yeah, we can find a video. Sure. So one of the things that happens, you get these ice flows where the water keeps moving and the ice starts to build up. So we're not going to watch all 4 minutes, but all you're seeing here is along the coastline, all these little pieces of ice, here they come, and they just stack up and stack up and stack up and stack up, and it's awesome.
Does it happen in Antarctica also?
I don't know I would assume yes, but I don't know that as a fact. Probably about that. Yep. My guess is the water underneath is like 1 or 2, but the top is definitely 0 or colder. Cool. Isn't it wild? Just like, it just never stops. Let's see if we can find the frozen waves, just as a quick video. We'll try in Lake Michigan.
Whoa.
Yep, so that's Lake Michigan.
Walking in it?
Oh yeah. Oh yeah. Doesn't that look like a fun place to hang out? So they have lighthouses because it's so big. But yeah, it's hardcore. Cool. Lake Michigan. All right. So they can be gigantic, like larger than you might, like, I don't know what else to say about it. Now, as we go through here, in temperate zones, just worth making this comment, lakes in temperate zones, lakes in temperate zones, what's a temperate zone?
like humid, kind of moist.
Maybe. It could be. It's not necessarily. You get 4 seasons very clearly defined within the temperate zones. So there's a clear winter, there's a clear summer, there's a clear autumn, and a clear spring. Now, lakes in temperate zones, they vary by season. And I'm not going to go crazy into the drawing because I'm not a great artist yet. I could be, I just don't really have the motivation for it. And there's a lot of stuff that happens. I am going to draw 4, count them, 4 lazy lakes. So there's a lake. That's a lake. It's going to be a lake. Here's a lake. Same lake. Here's a lake. I'll make it to the same. You know what I could do, and I should do? Everybody cool with that being a lake? Why wouldn't I just do this? Copy, paste. Copy, paste. Copy, paste. Boom. There's 4 lakes. to align with the, how many seasons in temperate zones? 4 of them. So, if we look at this, we have a few different things. What season do you want to start in, and how do you want to organize them? In autumn? Okay, which one's autumn? Left? All right, so I'll use this lovely orange color because that's what I think of with autumn. Autumn. I tried to tell my friends that I play games with, that I grew up with, like I've known them my whole life, about how silly it is that we call it fall, and they just thought like, oh, obviously that's why we call it, and it's not dumb. They just shut me down right away. I think it's dumb. All right. Okay. So, does wind exist? Okay. So let's have some wind blowing through here. And I'm just going to say, here's my wind. Does that look like wind to you guys? Yeah. All right. So there's the wind. Now, there's all sorts of stuff. We are not in a physics or an earth science class, so we're just going to kind of gloss over it. Autumn starts to get colder, right? So the water was warm before this. Now, cold and hot water, we're just going to work with the assumption that it works the way we want it to. Hot water does what compared to cold water? It rises. Okay? Which means this water was hot, right? And then it would get colder as you go down to the lake. But as we get cold winds start to blow over it, this water up top might start getting colder, right? So what we get is this in autumn, we get this sort of motion happening within our water. This is called the autumn overturn. Now, this is a really important idea because if you have a lake, and we'll just assume that it's not crazy deep, so it's a good, healthy lake, lots of thriving life. When stuff dies, where does it go? The bottom. Oh. And it's full of, where did you say? I don't know if fish go to heaven. I have no idea. Weird. Good answer. Not what I was expecting. Okay. All the nutrients and stuff are at the bottom, yeah? When this happens, what happens with all the nutrients? Maybe, but specifically, if I change these arrows just so they look nicer, here's all my nutrients. Here's all the good stuff. They start to cycle, right? Now we get all these nutrients all the way throughout the lake, which is a very important thing to happen because we don't want the top or the bottom to be unbalanced. Okay, so we were in autumn. Now we're going to be in winter. Okay, this is a weird idea, and if it gets too physicsy or earth sciencey, let me know because that's not the focus in here. What would you find on top of this lake in the wintertime? You're going to find ice. Now, here is just a weird idea that I think is super interesting. You guys know that as air or water gets hot, it does what? So careful. Yes, you're both of those. One, it doesn't freeze. It can't freeze if it gets hotter. But we talked about a second ago. It rises. Do you guys agree with that? Which means, let's just think this out. Cold water does what? It will freeze, but it drops. Now, we know this in the earth science and physics way, and I promise this I think is super interesting. I hope you find it the same. We have the words expand or condense. Things expand as they get hotter, and they condense as they get colder. And it's pretty natural because we can think about it as us. If we were outside and it was cold, and we didn't have like the ability to put on coats and stuff like that, we would huddle together. Like that's what people do when it's cold. Turns out that's what particles like to do as well. Do you guys agree that everything condenses as it gets colder? There's an issue, and this is very unique to water. Does water do that? Cold water will sink, and hot water rises, yeah? Until a certain point. So they don't meet in the middle, but here's a weird thing. There's a point where water changes from liquid to solid, right? And you have to get colder and colder to do that. How many of you guys have ever had a cup of ice water? Like, imagine a cup of water in front of you, and obviously you guys have, right? I like to ask silly questions that are obvious, easy ones. If you have a cup in front of you, we put an ice cube in it. What's the ice cube do? Hold on here, though. What does stuff do when it gets cold? Except for water. Whoa. The only thing that doesn't do this, water sinks until about 4 degrees Celsius. And then it starts getting less dense, which this is the only thing that does it. It starts expanding again. That is not normal with regard to any other substance that we deal with on a regular basis. Thank goodness for that, though, because what would happen if water did indeed get more dense and then it froze and it got denser? So maybe the whole lake freezes, maybe not. What would that ice do if it were more dense in all the water that it was in? And if you had a big sheet of ice covering a whole lake that sunk down, what happens to everything underneath of it? Everything would get crushed and die. This is super important. It's weird that it doesn't happen. Okay, here's a fun thought, and this is super strange. If you have the ice is at least 0 degrees Celsius. Okay, right underneath the water, right underneath the ice, you get liquid again. Dead. Oh, okay. He was falling asleep. If you need to go get a drink or stand up, should we do a quick brain break? Oh, okay. So we have 0 degrees up here. What do you think temperature is here?
Cold, like 0 degrees.
So it can't be 0. It'd be in the process of being ice. Can't be negative. It would be ice.
5 or 1.
It must be warmer, right? Okay, so it's 5 or 1. I'm going to say 1 to 3 degrees Celsius. 1 to 3. Like, it's super cold right under the ice. And this is so counterintuitive. If I go down deeper into this lake, let's say I don't know how deep this lake is, but let's go all the way down to the bottom. How cold do you think it might be?
Warmer.
It's going to be warmer. 4 plus degrees Celsius. It is so strange that this happens. It's counterintuitive because, one, we don't ever swim in ice cold water, normally anyway. But every other body of water that you swim in, like the ocean, for example, nice and warm on top, but if you go down just a few feet, it gets real cold real fast. Okay, that does happen in lakes as well, but there's a certain point where it just stops happening and just switches. Okay, in this situation, it's just kind of rough. All your fish and stuff still live because the water temperature is still okay. Your plants may revert because they've just gone through fall, but there's still sunlight they can get through, or like every other like coniferous plant that we deal with, maybe they just kind of hibernate, for lack of a better word. Okay, so we get through winter, which we're done with. Cool. What's next? Spring. So, okay, we're going to have this winds coming back through. Also, it's going to get really windy again tonight, if you guys weren't prepared for that. All right, ice melts. Everybody agree? Okay, which means this surface water that was 1 to 3 starts getting warmer again. Okay, and this is the really weird thing to think about. There's going to be a point where the water on top gets warmer than this, and the densities and stuff of hot and cold start to make sense again, which means the water that was on top will go down eventually, and we get this whole thing happening. Green seems like a springy color. All of a sudden again, we get this happening, which is our spring overturn, which is awesome because everything that just died over the course of the winter comes back. So not necessarily comes back to life, but all their nutrients get redistributed throughout the water. Or they were dead and they've been rotting all winter and now they get pushed up for those nutrients. So everything, yeah, some things come back after hibernating. Other things are just here. Okay, and then finally we get to where? Summer. I'm going to use pink. I can't use red because it's hard for me to see. Okay. Is summer yellow?
Yeah.
Okay.
Summer, red, yellow.
I would think red, but this color is really hard for me to see on the board. Is that one hard for you guys to see, or can you see it okay? You can see that? It's really hard for me to see, and I don't know why. I think I'm a little bit red blind, or red color blind. Like, I don't know what color this is. I don't know if that's, and maybe this is just a language thing. Is this color right here purple or pink? So maybe it's not just me. All right. So as we're looking at this, summer shows up and the water on top will start heating up again. But we're past the point of stuff being weird. So what we might be able to find is that even like in a really nice lake, maybe you get all the way up to 24 degrees Celsius up here. Like that's a nice warm, it's still chilly to us because we're 39 Celsius, but it's a nice warm lake. Okay, if you go down a little bit, warmer or colder? Colder. So maybe we get down to like 10-ish. Keep going down, what's it going to be? Yeah, it's colder still, right? Until autumn happens and these weird properties of water start to replenish everything. Okay, as we look at these, 4 very different example or seasons of the year, but they're all imperative to this. Now, does every lake on our planet undergo these 4 seasons? No, these are only lakes in which zone? Not just the USA, but they're in temperate zones. Now, have you guys ever seen a lake anywhere that you look at and go, oh, I'm not getting in that, that's gross, or this stinks, or whatever the case might be? Okay, as we look at this, whether it's murky, there's lots of different reasons, we already discussed that, but we're going to make a couple little comments. First one, we're going to get some vocab, so buckle up for this. Okay, the first one, we have lakes found at sometimes very high altitudes, and this is where they're really common, that just don't have the ability to get the oxygen needed or the sediment needed to start getting life and nutrients. In that situation, we get a nutrient poor lake, and I'm going to sneak in a vocab right here. Nutrient poor just means lacking nutrients, and then I'm going to sneak a vocab just inside so we don't have to define it. It means nutrient poor. We're going to say this is oligotrophic. Oligotrophic. Okay. An oligotrophic lake, what do we know about its nutrients? So not that much, or just like really lacking nutrients, right? Okay, and I saw this the other day, I just need to find it. I'm trying to remember what this, if you guys are interested in oligo and those things. Okay, so oligo, from Greek meaning few, or not that many, good call. Trophic, nourishment. So few nourishments is literally what this means. Oligotrophic lakes exist, first of all, but are commonly found in places where nutrients haven't been able to develop. It means the water's moving too fast for that to happen. Where in a river's course would that happen? Low altitude or high altitude? High altitude, because that's where all that snow melt's coming in, and you just haven't had a chance to develop that. High altitudes. I don't know why I put a hyphen in there, but that's okay. All right. They don't have the nutrients needed to sustain a lot of life. Don't misunderstand. There could be fish that still live in this river. There's just not like huge biodiversities that we're going to find. Might be fish, might not be. Okay. In contrast with that, if there's really nutrient poor lakes, oligotrophic, do you think there's really nutrient rich lakes? Okay. And this one, do you guys like it when you see why it's called what it is, or is that just a waste of time? I like it because it's a little bit of Greek and Latin learning. Okay, we also get a prefix meaning well. It's called EU. We get nutrient-rich lakes. So nutrient-rich or eutrophic. Eutrophic. Okay, which again, EU literally just means well, so well-nourished is what this means in Greek. Eutrophic, and that should be vocab, but I'm not going to go back. Lakes also exist at low altitude. They're common. And can I just say low alt? Okay. All right. Now, perfect. Does the law of detachment apply here necessarily? If a lake is at low altitude, then it could be eutrophic. If I tell you that a lake is at low altitude, does it guarantee that it's eutrophic? Many nourishments? Are you sure? Can you think of any lakes, and even imagine a lake, whether it's specific or not? Can you imagine a low altitude lake that doesn't have a bunch of this? Oh, so there's lakes that exist that aren't eutrophic even though they're at low altitude, right? Yeah. They can be either or. We're not necessarily saying only at high, only at low altitude. Like either one is possible, but I want you to make sure that you be aware of this. So Salt Lake is a good example. It's kind of high altitude, but that's okay. It's a lower altitude than mountains, and it's eutrophic, which means there's not a lot of nutrients in it. Why not a lot of nutrients there? So careful. I only wanted that because it was a nice if-then place. Like, let's leave the geometry behind. Too salty for life. Are there other reasons that lakes might not be great? What about it? That's always going to be a correct answer, Fred, but I'm always going to ask you to go further. Yes. So I'll tell you, I went to Iowa several years ago on a big camping trip, and we were at like a bunch of little lakes, and we fished, and it was super fun. Wouldn't dare eat the fish. Nope, we caught so many fish, wouldn't eat them. What about the environment, Fred? So they grow a lot of crops in Iowa.
I think I might know. Chemicals?
Fertilizers. The nitrate levels in that lake. I wouldn't swim in that lake. We were on a beautiful lake. Couldn't go swimming. Couldn't eat the fish. Not the radiation. It's the nutrients. All the pollution and stuff caused by humans. It's a huge issue. Okay. Now, as we go through here, some lakes are really big. We saw that. Some lakes are so large, in fact, we got just a lot about lakes today. Some lakes are so big that they're cut into zones. Some lakes are so large I'm going to say big because it's a shorter word, that ecologists classify zones within a lake. I'm going to let you guys catch up. It is so big that you can't just talk about the lake. You can't talk about the ocean because it's not the same everywhere. Okay, they classify zones, and if they're an ecologist, they're going to do this based on the life and stuff around, right? Okay, we're going to say zones based on biodiversity. Now, I don't know if we use this word all the time. Have we ever actually defined or thought about and talked about what biodiversity is? You probably have an idea of what I'm referring to every time, but I just want to double check. What's biodiversity?
The diversity of all organisms, kind of.
What's diversity?
Like the difference between all living or non-living things.
So, possibly. I'm not going to say you're wrong, just because
It's like diverse.
Animal living together.
lots of different animals is high biodiversity. Only a few different types is lower. Okay. How diverse are the different types of animals in biological life? Okay. We can do it by biodiversity, which directly relates to a couple other things. Sunlight, and sunlight. Because I think it might be reasonable to say the amount of light that somewhere gets directly impacts how biodiverse it is. Okay. We're going to sneak in one more definition, and then we're not going to finish this today. There are 3 main zones when we're talking about real big lake. The first of these, 3 zones that we'll look at. The first is the littoral zone. Not like literally, but pretty close. Littoral. The littoral zone. If we want to be obnoxious so that we can separate it, I don't mind if we call it littoral, but that sounds odd to me. Okay, the littoral zone. This is where you're going to find most light. Where in a lake would you find the most light?
Non-murky.
So, love that answer. Let me rephrase that. If we're looking at a lake from above, are you going to find like light penetrating the best and to grow plants in the middle of the lake or near the edges? Near the edges, right? Because the water's less deep. So we'll just say this is littoral zone is going to be closest to shore. Closest to shore with light penetrating to the bottom. And before I write to the bottom, can we just say fully? Would that make as much sense? If I say light penetrates water fully, does that imply that it goes all the way to the bottom?
Yeah.
Fully. Okay. In this situation, what's going to grow really well if you have light going all the way to the bottom?
The environment, like in terms of food.
Stop saying ground. It's specific.
Plants. Plants grow, and I'll say prosper. They do really well. All right. We will start tomorrow talking about the limnetic zone. Too slow today, or was it still like I didn't get through much? Do I need to speed it up, or is it lively enough?